Okay, in example 2, we're going to determine the exact values of sine, cosine, and tangents of theta equal to 7 pi over 4. So you can see I sort of started off the question. So I'm looking for sine of 7 pi over 4, cosine of 7 pi over 4, and then tangent of 7 pi over 4. So before I can do this question, I need to figure out which quadrant this angle would fall in, and then figure out the related acute angle that corresponds to it. Okay, using that I can use it to help me figure out the sine, cosine, and tangent of that angle. So one way to figure this out is to recognize that because I'm looking at a fraction of 4, I'm starting at 0 here, and over here I know I have pi. Now if I wanted to figure out what quadrant this would be in, I know that this would be 4 pi over 4. So this would reduce down to pi. So that's one way to figure it out. Because I know I'm looking at a fraction of 4, I can use 4 pi over 4 to help me figure out whereabouts this angle might be. Okay? So far, I know that I'm looking at 7 pi over 4, which is greater than 4 pi over 4. Okay? Halfway, this would be 2 pi over 4. So what that tells me is that every quarter of a rotation, I'm traveling 2 pi over 4. Okay, so this is 2 pi over 4, this is 4 pi over 4, that would mean this is 6 pi over 4, and all the way up till here, this would be 8 pi over 4. Okay, and so the fraction I'm looking at, which is 7 pi over 4, the ratio I'm looking at, which is 7 pi over 4, has to fall somewhere in between 6 pi over 4 and 8 pi over 4, which means the angle that I'm looking for has to be in quadrant 4. Okay, so what this means is I'm going to draw my little triangle here, and I know that this angle here, if this is 8 pi over 4 and this is 7 pi over 4, this angle here would be pi over 4. Okay, there's your related acute angle. Okay, so in case you're wondering how I figured this out, a full rotation would be 8 pi over 4, and the rotation I'm looking at is 7 pi over 4. So the difference between 8 pi over 4 and 7 pi over 4 gives me pi over 4, which is how I got that angle up there. Okay, so now I know what the related acute angle is. My next step is to figure out whether my angle is, my sine, cosine, and tangent angles would be positive or negative in that quadrant. Okay, because then from there it's pretty easy. So I'm going to use a cast rule. And so the only ratio that should be positive in quadrant 4 is the cosine ratio, which means if I'm trying to solve for the sine of 7 pi over 4, my ratio will be negative, and the related acute angle that it would be similar to is just pi over 4. So I'm rewriting this expression using the cast rule and the related acute angle. Okay, so you're always going to rewrite it using the cast rule, so that'll tell you whether it's positive or negative, and then the related acute angle which you solved for. And then from here, this is really easy because I'm going to look at my special triangle again, and I'm just going to look at the sine of pi over 4. So the negative stays at the front, and pi over 4 is opposite over hypotenuse, which gives me 1 over root 2. Okay, so that's the exact value of sine of 7 pi over 4. I can do the same thing for cosine. Cosine is positive in this quadrant, so I know I'm going to have a positive value, and the related acute angle is pi over 4. So cos of 7 pi over 4 is equal to cos of pi over 4. And again, if I look at my special triangle, pi over 4, I'm looking at adjacent over hypotenuse, so that would be 1 over root 2. And then finally, tan of 7 pi over 4, tan is negative in this quadrant, and the related acute angle is pi over 4. So this is going to be equal to negative tan of pi over 4. And using my special triangle again, tan is opposite over adjacent, so I'm going to look at opposite over adjacent, so this gives me negative 1 over 1, which is just negative 1. Okay, so rewrite it using the cast rule and the related acute angle, and you'll be able to figure out the exact value for any trig ratio. Okay, for the last example, it says the arm of a boom crane is 10 meters long. Because of the location of the construction site, the angle of inclination of the boom, of the crane, has a minimum value of pi over 6 and a maximum value of pi over 4. Find the vertical displacement of the end of the boom as an exact value. Okay, so what we're told is the arm of the boom crane is 10 meters long, and we're told that the angle of inclination of the boom has a minimum value of pi over 6 and a maximum value of pi over 4. Now remember that pi over 4 is the same thing as 45 degrees. And so if this is the maximum, then this is the minimum, which must be 30 degrees. And we know that the pi over 6 is equivalent to 30 degrees. And so you're asked to find the vertical displacement of the end of the boom as an exact value. And again, because the question says exact value, you should recognize to use similar triangles. So I started off the question. So here's my crane. And what I know is that the minimum angle that can be made is pi over 6. And the maximum angle that can be made, so that's the minimum angle, the maximum angle that can be made is pi over 4. Okay? And I'm also told that the arm of the boom is 10 meters long. So this diagonal distance here is 10 meters. Okay? So depending on how the crane is moving, it can move at a minimum angle of pi over 6 and a maximum angle of pi over 4, which means the vertical displacement we're solving for is the distance between the tips that are there and there. Okay? So what I did is I separated this into two sort of triangles. So what I know about the smaller triangle is that this angle here is pi over 6. I'm just going to close this up to make a triangle. And so that means this is a 90-degree angle. And I also know that the diagonal distance here is 10 meters. Now the side that I'm looking for is what I'm going to call H1. Okay? So that's one of the vertical distances that I'm looking for. The question asks for vertical displacement, so I'm only worried about the vertical distance that's here. Okay? In the larger triangle, I know that this angle here is pi over 4. And again, I'm going to create a little triangle here. This is my pi over 2 angle. And I also know that this is still 10 meters. Okay? And the distance I'm looking for is what I'm going to call H2. Okay, the second height. Now, in order to solve this, this is exactly what you did in grade 10 when you were given an angle, one of the sides in the right angle triangle, and then you're solving for the other one. Okay, so here I'm given an angle, and I'm trying to solve for the opposite side, and I know the hypotenuse side. So the ratio that combines an angle, its opposite, and hypotenuse sides is actually the sine ratio. So I'm going to use the sine ratio to help me figure out what the exact value of that height is. So sine of my angle is equal to the opposite side, which is H1, over my hypotenuse, which is 10. Now, in order to solve this, I can actually replace sine of pi over 6 with the exact value that represents it using my special triangles. So sine of pi over 6 is the same as opposite over hypotenuse. So pi over 6, sine of pi over 6 is equal to 1/2. So I can actually replace the ratio with the exact value that represents it. And so what I end up with is 1/2 is equal to H1 over 10. So now this is just a proportion that I need to solve for the height. Okay? So this part here I know the exact value of using the special triangles, and I get 1/2. And then from here, just a matter of solving for H, so I'll cross multiply and I'll solve for H. And so I get 2 times H1 equals 10, which means H1 is equal to 5 meters. So now what we have is the length of this side here, and that is 5 meters. Okay, so one vertical distance is solved for. Now I just need to solve for the other vertical distance, and then I can find the difference between them. So again, I'm going to do the same thing. I have an angle that's given, and I'm going to use my grade 10 concepts to help me solve this. I have an angle that's given. I'm looking for the opposite side, and I also have the hypotenuse. So again, the ratio that combines opposite and hypotenuse to an angle is the sine ratio. So I'm going to set it up again. So sine of pi over 4 is equal to my opposite side, which is H2, over my hypotenuse, which is 10. And again, in order to get rid of this ratio, I can use my special triangle, and I can find the exact value of sine of pi over 4. And the exact value of that is 1 over root 2, so opposite over hypotenuse. And then the right side is the same still. And now all I need to do is to solve a disproportion. So cross multiply and solve for the height. So if I cross multiply, I get root 2 times h2 equals 10. Divide both sides by root 2. And so I get h2 is equal to 10 over root 2, except you need to rationalize your denominator because you can't have a radical in the denominator. So you're going to multiply the top and bottom by root 2. And so you get h2 is equal to 10 root 2 over root 2 times root 2 is 2, which means the second height is equal to 5 times root 2 meters. Okay, and so your vertical displacement would just be the difference between the taller height and the shorter height. And so the taller height would be along here. So this is 5 root 2 meters. And so if I find the difference between this and this, I'll be able to figure out the vertical displacement. Okay, so the vertical displacement is 5 root 2 minus 5 meters. Okay, and that's it.